Hello and welcome to this Kitware webinar. I'm François Mazin, the Assistant Director of Scientific Visualization at Kitware Europe. And today we invited Timothée.
Hi everyone. Thanks François for the introduction. So I'm Timothée Chabat and I'm a R&D engineer at Kitware Europe.
Okay, so today we will discuss about ParaView and how to leverage the power of your GPU in this software. So Timothée and I both work at Kitware, so I will present a bit what we do. Just before starting, I just want to mention that this is a live streaming, so there is a chat on the right part of the Vimeo page. So do not hesitate to write your question or to try to interact with us. We will try to answer and to have a question and answer session at the end. Usually there is some small delay between when you enter the question and when we see it, so do not panic if we don't see it right away. So what do we do at Kitware? So we develop open source softwares that we call platform, because they are much more than just softwares. They are some modules that you can use to build your own solution based on this module. So this is open source software that targets mainly scientific application in several areas, like computer vision with image processing, data analytics, scientific computing, scientific visualization. This is what we will discuss today with Timothée. Medical computing with mainly 3D slicer, and software solution. I'm sure you know CMake, the almighty build system, with all the ecosystem like C-Test, C-Dash, in order to better manage your software process. So this is open source solution. So Kitware as a company provide professional service, various type of service, from training, support, development if you want to push new feature in the open source softwares, and grant collaboration for your R&D project if you want to push forward the state of the art of what we do with authors, of course. Today we will discuss about ParaView. So quick reminder on this software. So this is basically a front end to VTK, the visualization toolkit, which is also an open source software developed at Kitware. So it's dedicated to explore and analyze very large data. And when I mean large, very massive data dedicated to cluster computation and so on. And this is the topic of today, because usually when your data are very large, it uses lots of RAM and lots of CPU, and Timothée wants to show you how to leverage your CPU, your GPU, sorry, to avoid some issue with the RAM consumption and to improve performances. So Timothée, the floor is yours.
Thanks, François. So yeah, as François said, today we'll see how to use the GPU in ParaView. Maybe some of you knows that there is actually two ways of using the GPU in ParaView. The first way is using representations. So basically how ParaView will display your data on your screen. And the second way is VTK-M, which allows you to build a whole pipeline directly using the GPU. VTK-M is exposed in ParaView using a plugin. Some of you may already tested it. But today is not about VTK-M. Today is about how to use representations to visualize the data you have. So with that being said, let's jump right in. And so to demonstrate my points, I'll be using a large volumetric dataset. Let's open it.
What is large?
So yeah, this dataset is 500 by 500 by 500, and it takes 2 GB in memory to load. So now with this kind of datasets, usually what you want to know is to get some information out of it. There are several ways of doing so. There are several filters. You can set up whatever backplane you want. One filter that is very common to use is the slice filter. So, for example, if I want to use the slice filter in order to gain some insight about what's going on in my dataset, I can create the slice filter and just hit apply, for example. And so, yeah, now I have my slice of my dataset. And so a single slice is not enough. So maybe I may want to move the slice forward because I want to change the location. And each time I change the location of my slice, I can't see the result right away, right? Because I have to hit apply every time I'm changing my slice. But there is actually a way of doing that interactively using the GPU. So GPU like representation in ParaView are mainly relying on the GPU to do their work. And so using the GPU in ParaView allows two main things. The first one is more interactivity, and the second one is sometimes you can save some RAMs. So for interactivity here, so for the slice, so for each time I change the slice, I have to hit apply and I cannot really see the result right away. But there is a way using your GPU and a representation to do that more interactively. So the way of doing so is by using the volume representation. So using the volume representation, you first have this kind of rendering. Maybe you're very familiar with it. But there is actually some properties of the volume representation that allows you to create a slice. So the way of creating a slice in the properties is by going in the properties panel. In the display properties, there is a volume rendering section. And so in this volume rendering section, you have the blending mode, so the blend mode. And in this blend mode, you have actually three modes, which is composite, the usual way of visualizing your volumetric data. And then you have isosurface and slice. And so if I select slice, for example, you can see that I have directly a slice. You can also see that my opacity is staying the same as when I'm displaying a volume. So if I want to have a full slice, like the output of the slice filter, I can just change my column up on the right and just go the whole way up with the opacity. And now I have the same slice I had before with the slice filter. And what's really cool with that is that first, it's much faster to compute. Maybe you didn't feel that because of the streaming, but the slice filter took a few milliseconds to compute. But this slice is almost instant, even though the data is very large. And so you can see that if I change a bit the position of my slice, it is directly computed on the fly. And so you have much more interactivity to see what's going on into your dataset. Because this data is so large, it's still a bit laggy. But in a smaller dataset, let's say like 300 by 300 by 300, it's very smooth, and you can just scroll the way all along your volume. And so controlling the slice in this mode is just exactly as controlling the slice in the slice filter. So you have the show plane thing to control the widget. You also have the origin, the normal. You can choose the X, Y, or Z normal, the camera normal, and things like that.
Okay, great.
So yeah, so this was for the slice. So the slice is just one way you can use to gain insight of your data. Some other things you can do is, for example, creating an isosurface. So let's do that. Let's jump in and try to create some isosurfaces. I just put this in outline mode again. And so just so we can compare the RAM footprint now. So I open the memory inspector of ParaView, and we'll check the memory that ParaView has loaded into the RAM. So right now, you can see that my PV server, so just as a quick disclaimer, we're using a PV server here because what we're doing is very GPU intensive, and we don't want, and because streaming is also very GPU intensive, we don't want to use the same GPU for processing all data and streaming, right? So just a quick note, we're using a PV server here, but it's not relevant in this webinar. It can work on your laptop or in any really computer that has a GPU. That being said, so if we so just to keep that in mind, right now we have 3.5 gigabytes loaded in memory.
3.5. Okay.
Yeah. So now let's say we want to create some isosurfaces. So let's do so. Let's create the filter contour. Go up to the properties. And now let's say, I don't know, I want to compute 10 isosurfaces and just like linearly spaced. So let's generate the spacing and apply the filter.
It's slow.
So yeah,
It takes time. Yeah.
It takes a bit of time because of the size of the data, not instant. And
maybe 5 seconds, something like that.
Something like, yeah, 3 seconds for the execution of the filter, and then a second for creating the surface representation of the output of the filter.
Okay, so 4 seconds.
Yeah, something like 4 seconds. So we have the isosurfaces, which is good. And we can see that we can that creating the isosurfaces took 4 gigabytes of memory, because now we are at 7.4 gigabytes more, so more or less 4 gigabytes, which is twice the size of the initial data. But no, there is actually a way of creating in a much faster way isosurfaces and by taking much less RAM. So let's hide these isosurfaces for now, and let's get back to our initial data. So let's select again the volumetric rendering and go down to the options in the volumetric data, and just as we've done with the slice filter, now we will do the same with the contour filter. So we choose the blend mode to isosurface, and you can see that in less than a second we have no isosurfaces for all data. So same thing, let's say I want to create 10 isosurfaces. Let's generate them. And right away,
it's instant, yeah.
Yeah, it's almost instant, even though the data is very. Well, that being said, you can see it's very flat, and you can see really what's going on. But there is an option to correct that. That is the shade option in the volume rendering properties. And so if you enable the shade option, you can see that now the result is almost the same as the isosurfaces that we saw earlier. So to be clear, the thing is the same. It's not shaded as exactly the same as before. But the isosurfaces are correct, and they take. And so if we go to the memory inspector, the memory taken by the data hasn't changed, because we nearly haven't allocated anything in RAM. Everything takes place in the GPU at render time.
You mean it's free?
It's basically RAM free.
Yeah, maybe 100 megabytes or something like that. Yeah.
Yeah, you still have to create the volume representation first, which takes some more RAM. But once you created the volume representation, it's free.
Great.
And yeah, as you saw, it's very fast. So you can interactively design the value of your isosurfaces and then displaying them right away. One thing to mention though, what we see here is just the visualization, the end result, like the image of the isosurface, because everything takes place at render time. However, if you want to export the isosurfaces on your disk, that is the actual geometry of your isosurfaces, you will have to go through the contour filter, because everything that takes place in a representation just gives an image, and everything that takes place in the pipeline gives actual data that you can write on the disk and that you can process later on. So yeah, this is also important if you want to process further these isosurfaces, for example, by applying the wrap filter or any filter you want. You can't apply filters on top of a representation. You have to go to use the pipeline.
So to use a control filter in this case.
Yeah, exactly. Yeah. Use a control filter in the case of the isosurface.
Great.
So yeah, these are examples of what you can use. There are other things, there are other representations that you can use in order to leverage the power of your GPU. And for example, we can talk about glyphs. So for that, let me just load a new dataset, because this dataset didn't have any scalar field. And let's open a dataset that has a scalar field. So
vector field.
A vector field, yeah, sorry. A vector field, yes. So this dataset is a bit smaller, but since it has a vector field, it will be much nicer to work with using the glyph filter. So first way of creating glyphs for a dataset is directly using the glyph filter array. So if you use the glyph filter, you can choose the orientation array and the scale array. We have to match the attributes of the orientation and the scale. So let's just match that. And then if you hit apply, then you have some glyphs. But the result is maybe not so nice, so maybe I want to change the scale factor and hit apply again, and so it will compute again. Even though it's not too long, you still have to hit apply every time you change a parameter. And so maybe now I want to change the array resolution or things like that, and hit apply again. And yeah, every time
it's a long process, you mean?
Yeah, it's
try and error.
Yeah, it's really try and error, and you always have to wait at some point.
Yeah.
Another issue with this filter is actually it duplicates the whole geometry per point. So if your input geometry is very large, like the geometry of the glyph is very large, you may run out of memory. So let's say I go all the way up with tip resolution and shaft resolution of the arrow. If I hit apply now, ParaView will crash because...
Don't do this.
Yeah. ParaView will crash because I won't have enough memory to create all of the glyphs. So what we can do is using the glyph representation. So as before, we will just take the basic data and change the representation to 3D glyphs, and the result is not really as expected. And because if you use 3D glyphs on an image, a structure grid, it will only create glyphs on the surface. So if you want to create glyphs on the actual points of your image, you have to use a special filter which is called mask points. So what mask point does is that it allows you to choose either all the points of your datasets or some random subsample of your points of the input dataset. So you can use the random sampling options of the mask points filter, and it allows you to choose 5,000 points from your input dataset. You have several methods of random sampling. Random sampling is quite good in most of the cases, and you also have some partially stratified random sampling, which has a better distribution. But for what we want to do, random sampling is very nice. And so we hit apply, and what this filter gives is just points. There's no cells, there's no topology information, it's just points, which means it's very, very lightweight. So even though I didn't activate random sampling and took all of the points of my input dataset, the result will still be smaller than my input dataset. So this is very useful because once we have the points, that means we have all of the information to create the glyphs. So now we can use the glyph representation on the mask point, and we can't see really anything because the scaling is off.
Yeah.
I mean, we can see, but it's very, very small.
Yeah, very small point on the screen.
Yeah. So you have to, just like before, go to the display properties and set for the glyph parameters section. And now we can activate scaling.
Oh, better.
And now we can see what's going on. And so with that, we can orient the glyphs, for example. So we can choose to orient, and directly we have the result. So the result is really computed on the fly, on the GPU. So it's really fast. For example, if I want to design a bit my arrow, I can increase the tip resolution, I can increase my shaft resolution, I can increase the tip radius, but if I go too wide, it's really not good looking. So let's just put that to 0.05, for example, and maybe reduce that to have some thinner arrows.
And it looks very interactive when you change the slider.
Yeah, it's really like it's real time. It's really real time for this. And so of course you have the control you have like on every other representation. So you can choose the color, you can choose the opacity of your glyphs. So if I go to the color editor and enable opacity mapping for surfaces, you can see that I can control the opacity for my glyphs.
Similar to volume rendering.
Exactly. And what is really great about this representation is that it's almost it doesn't scale with the size of your glyph, because only the glyph geometry is only stored one time in the CPU RAM, in the memory. The position, the orientation of it, the array that describes the orientation and the position for each points is directly sent to the GPU, and the geometry of the glyph is only stored one time. This is a process that is called instantiation. For this, you know a bit about OpenGL and rendering stuff. And so the 3D glyphs representation takes advantage of this instantiation, and so with that you can create very, very high quality glyphs with almost no cost. Well, at least it will not scale with the size of.
Will we look at the memory inspector just for?
Well, because we only have 5,000 points,
okay.
Even though we were to use the glyph filter, it wouldn't take that much memory.
No, not less than 1 GB.
Yeah, it's really lightweight so far. And so what's great is that if I were to use the glyph filter on the whole dataset with all of the points without any masking, ParaView would likely crash because there's a lot of points. And now if I would want to create glyphs on all of the points of these datasets, oh, it's not the right filter, you can use the filter point cloud, convert to point cloud, and use the cell generation mode no cells, because we don't need the topology information. We don't want cells to use the 3D glyph representation. We just want the points positions. And so if I hit apply, I have now a point clouds. And if I use the 3D glyph representation, you can see that even though there's like millions of glyphs, it's instant rendering.
Impressive.
And so if I go to the orient, if I just want to orient the array, yeah, it's just oriented directly. Usually you don't want to do that because it's way too much glyphs, but it really depends of your dataset. It depends on what you want to do. So if you have a lot of glyphs to instantiate and you're not sure, and you know your glyph geometry is very high resolution, and you just want to do a lot of glyphs, the 3D glyph representation can really help you save some RAM and save some interactive and gain some interactive.
Okay, we have some question in the chat. Ian asked, what is a large dataset for people? So I let participants answer. Another question from Ali, which data formats can be used with volume rendering or volume representation? Is it possible to use with H5 dataset?
So it's not about the file format, but more about what the file format describes. So volumetric rendering, the basic mode of volumetric rendering, so let's hit that. And change. We want to see a bit what's. So this mode, the basic mode of the volume representation, that is the blending mode, which is called composite. This is supported by every dataset that has 3D cells. So that is the structured grid, the unstructured grid. However, the other blending modes, so that I shown, so isosurfaces and slice, is only supported for image data, that is structured grid. It is not supported for unstructured grid datasets.
So you mean it's not linked to H5 actually, but the actual data which is represented by the H5 format.
Exactly.
Okay. Another question from Bastien, can these representations be used with animation to create videos?
Yeah, of course. I mean, they're regular. It's exactly when you use it's exactly the same when you use surface rendering, right? Or I don't know, point Gaussian rendering or anything, point Gaussian representation. You can take screenshot of them. They will be there. They will exist as an image. You can animate some parameters of the representation. So yeah, of course, it's totally compatible with the animation module of ParaView.
Okay, great. There is no more question. Do not hesitate to put them in the chat. So Timothée, is there other topic to discuss before closing this webinar?
Well, there isn't much thing I can go into depth right now, but I can mention a few more representations that can be helpful to you guys. So, for example, what you may want to do is warp your dataset using some scalar field or vector field. There is also a representation for warping directly on your GPU, and this representation can be found in a plugin. So the plugin, so if you want to know which plugin it is, you can go to Tools, Manage Plugins, and it's called the Embossing Representation. So this plugin allows you to have filters. Well, there's actually two representations. There's one representation that allows you to directly warp your datasets. And there's another representation that allows you to influence the shading regarding a simulated warp. It's just for the shading, the second representation. What you can also do using the representation properties is transforming them. So if your objective is only to change the position of your dataset, but just on the screen, just because you'd like to, I don't know, to resolve some depth conflict, or if just you want to move it on the right a bit, you don't have to use the transform filter. So for those who don't know, there is a transform filter that moves the data around, but it actually copies the whole data. It copies the whole geometry and topology. If you just want to move a bit your datasets, then there is the transforming section of the display properties. So you have translation, scale, rotation, and this is available for the whole type of dataset, for every dataset you can think of. And lastly, there is also the streamline representation, which is also available via a plugin. So if you go to Tool, Manage Plugin, it's called the streamline representation. And this streamline representation allows you to have some animated streamlines directly on the screen. So it's a bit different from the output of the stream tracer. It's more like, let's say, a video that you can see. It's not actual data that has like fixed output. But it's still very useful if you want to try some great sense.
Just to mention that about Streamline, we have another webinar from Mathieu Westphal, so you can check it and you will learn everything you want to know about Streamline representation and so on.
Exactly.
Okay, I think we are done. We are at the end of this webinar. Let's move back to our. So I can see other question in the chat. Question about open form format. So we are not expert in ICEM structure and so on, but basically as soon as you can open your data in ParaView, you can use the representation and use GPU and so on. So it should work.
Yeah, exactly.
Let's wait maybe few seconds. There is still other question in the chat. We try to sum up what we see today. So we discover how to not use classic filters that is RAM intensive and CPU intensive, but use some GPU way to do the same action, which has lots of advantages like performance, as we see, and low RAM consumption. So this is really great alternatives when you have some great GPU to use. And some drawback we thought is if you want to use the output of this representation, it's not possible, just for video, screen, and interactive. And in this case, you have to go back to the classic filter to perform more. Okay.
Exactly. It just serves at the end of your pipeline, or if you want to quickly visualize what's inside.
Okay.
So yeah, if there's any other questions, feel free to ask them. Of course, we'll be good to answer.
Yes, I display some way to contact us. We are always happy to have feedback, positive, negative. We have a discourse with a very live community. I guess most of participants also participate to this discourse, so thank you very much. Thank you, Timothée, for your expertise on this domain.
Thank you, François.
And for everyone, thank you for attending. Keep connected for the next webinar. We don't know what we will discuss, but this is always a great technical subject around our tools. Thank you, guys. Have a nice day. Bye.
Bye.